Hello, welcome to our presentation today. We're going to be speaking about anti-patterns, reinvent the wheel, Swiss Army knife, and vendor lock-in. The first anti-pattern is called reinvent the wheel. It's also known as design in a vacuum and greenfield architecture. Design in a vacuum, it's basically the meaning of it is building something in a closed space from which all the air and other gases have been sucked out, or figuratively meaning in isolation or without interacting with other people or other real-life experience. The latter applies to us software engineers. Root causes: pride, ignorance, laziness, possibly. Ignorance is probably, in my opinion, one of the biggest factors. We're not sure what's available. Unbalanced forces will be there's a set of best practices are used when a company makes changes that could expose or create hazards. So management of change is risky. And also technology transfer. Maybe you're changing technologies, you don't know what's available out there. And finally, Webster's definition is to waste time trying to do something that has already been done successfully by someone else. Now, the evidence that we're talking about today is the fact that reusing software is a dying art. We have so much new technology today to choose from, and a lot of appealing software solutions are coming out that might fit a problem better than others. Developers choose their own technology, ASP.NET, React, JavaScript, C++, Swift. Reuse is very time consuming, and it may not fit the technology that we're trying to put together. In a study of more than 32 software projects, researchers found no evidence of successful reuse. Knowledge is not enough to avoid doing it. If so, it would be less common. Technology is moving so fast that it makes it a challenge to stay current and even avoid this pattern. So some of the symptoms and consequences for using this pattern. One thing we find out is that we have closed system architectures. We might develop for the web, and maybe the components we need or could use are in C++. Or we're using iOS and Swift. Probably can't use C# components. If we follow this pattern, we will build immature and unstable architectures because we're moving too fast. We are not taking enough time to build our systems today using good patterns, practices, and interfaces. Because when you share it with somebody, they're going to ask, well, what's the interface? How do you call it? What methods and public properties do you have available? So you have to think about these things before you put them together. Inadequate support for change management and interoperability. Each team has their own budget. So we need to get management involved to make this happen. Managers already have enough stresses because the schedule, budget, and budget problems. We're trying to get software out to the end user as soon as possible, and we're trying to replicate what the old system was already doing. And if we do take time to build a component, coordinate with other teams, and coordinate with the company, use its standards, we do put managers at risk because it could take longer to complete it. And we're trying to get code out there to beat the competition. What are some solutions that we can consider and try to avoid using this pattern as much as possible. We find documentation of components that are available to use. Um, you can check with the architects or experienced developers. Someone who's even the business analyst might be able to help to let you know where things are stored. We can always use APIs. The API developers usually have reasonable interfaces that you can call and process certain parts of your business and your application. You can always use NuGet packages for C# or NPM packages for JavaScript solutions. Also, you need a plan up front if you're going to explore this, because and if you're using Agile, this is called a spike, and usually you can get buy-off from the team to do this analysis. And then lastly, you need to convince management it is a good idea to reuse code, and it can save the company money. It's much easier to call a function that's been written to process, for instance, the cost of a flight, or process, or maybe go get a seat map. Things like that can save tremendous time. You just have to convince management of that. In summary, reinventing the square wheel happens when a developer or team with insufficient knowledge attempts to recreate the product, but frequently doesn't have enough time to do it, so it's going to be worse. And then if you ship bugs, then it's going to take longer in the end to be more costly. This is an interesting real-world example of the pattern. It's about the new Coke debacle. And if you know anything about this, Coke was losing money in the 90s to Pepsi. And a lot of people like the taste of Pepsi better. So Coca-Cola reformulated their product and named it Coke 2. The new Coke failed and was a major failure, so they went back to the original formula and named it Coke Classic. You've probably seen that in the stores. The new branding was successful, so they didn't have to reinvent the wheel, and they tried to but failed. So one thing as a developer you need to know is domain knowledge. How does a product work, and how many components are available to do what you already need to do? The more you have this domain knowledge, the better. Then you'll know what to look for. Savings of reuse can go from 15 to 75% of development costs, and reduce defects, and have a reduction of 2 to 5 times in time to market. You definitely need to look for opportunities to reuse components that are already built and tested and been out there for a while. Even if maybe they're not written in the newest, latest technology, you still need to use them, and you will have a huge cost savings. Thank you.
Thank you, David. Hi, everyone. My name is Afake Hilda Abugidi, and I'll be speaking briefly about the Swiss Army knife architecture anti-pattern. It is also known as the kitchen sink or the one-tool wonder. The root causes are a lack of clear purpose, an attempt to meet all possible needs. The Webster definition defines it as a universal solution to all needs, a universal antidote, which is likened to a drug that cures all ailments. And we all know that there is no such thing. To give a good description of this anti-pattern, I would like to talk about how it manifests. It can be applicable in an interface or a class. It is characterized by excessive number of method definitions in the cases of an interface or methods in the case of classes. It is prevalent in commercial software interfaces and in student work. I wonder why. And also, it goes against the object-oriented principles of the single responsibility as well as the interface segregation. And just to give an overview of what those two solid principles are, the single responsibility principle is a principle that talks about a class or an interface focusing on one single goal, doing one thing and doing it well. While the interface segregation is a principle that talks about abstracting functionalities based on a family of functionalities that focus on one thing and one thing only. Now that we have a good overview, let's see what causes people or developers to fall into this trap. The first listed is designing without planning. And this just like it's written, going into designing or properly implementing your code without actually planning means you are just writing out of your head, and that can lead to you falling into the trap of Swiss Army knife anti-pattern. That means you just try to solve multiple problems or even a single problem and utilize all the tools that you need to solve that problem, and you try to do that in one class. It can also be caused by a myopic view rather than having an overall big picture of the system. A myopic view being that you are seeing the problem from just one angle rather than seeing the big picture and seeing how solving this problem interacts with other components in the system and how the different subsystems come together. We also have single class solution to all possible problems listed, and that is exactly what it is, trying to solve all the problems in one single class, and also not considering context. So what this results in is debugging difficulty because you cannot properly abstract the code and you cannot tell where something is happening. It's difficult to track a bug down. It could also be challenging for other developers to understand the code and then review it. Because if you don't understand the code that you're reading, how can you review it? And it's difficult to understand when you just have different methods doing different things in one class or in an interface. Then we talk about difficulty to maintain code. And this also results because it's difficult to understand, it's not simplified, and how do you maintain it? To maintain, it needs to be simplified, it needs to be flexible, and you can easily track down bugs, and that way you can make things better. And lastly, we talk about documentation nightmare. If you don't properly understand code, it's difficult to document for someone else to understand, especially for new developers coming into the system. You need to properly highlight what the system is doing, and if it's not clear, if it's not simplified enough, that becomes a nightmare to achieve. So what are the solutions to the Swiss Army knife architecture anti-pattern? First is having a profile, which involves documenting how a complex technology will be used, having a good design, having a good plan before you begin. The second point I have here is designing first before you code. Most times, especially in student assignments, we just go ahead, write on, we think we understand the problem, and we just start to code. Without a good design, it will be difficult to follow the solid principles if you're designing in object-oriented programming language, and stick to those guidelines that help have a better, flexible, reusable component in your system. And abstraction is also key because that helps you segment families of functionalities into their different interfaces. And that simplifies the process, simplifies the system. It makes it easy to understand, easy to debug, easy to document. Another solution is keeping the big picture in mind and not looking at just a subset of the system and trying to solve one problem only and not considering how it affects everything else. And then lastly, I had following the single responsibility and interface segregation principles from solid principles. Having a class do one thing and do one thing well, as well as abstracting families of functionalities into different classes, are what this point is talking about. And that greatly helps simplified code. Here is an example of a Swiss Army knife interface. So I have a Swiss Army interface, and without reading through the different methods that you have there, you can clearly see that they do different things. Right away, you can tell that separating these into different classes will be beneficial. It will be easier to read, it will be easier to understand, and it will be easier to debug. Functionalities like authentication and log on can go into an authentication service. The file functionality, the open file, close file, read file, assuming we're acting on a file, those can all go into a file helper class. Same goes for the math helper class. Functionalities that deal with math operations can go into that class. And this is just an example. In real life situation, Swiss Army knife interfaces have a lot more methods and method signatures in them, and that can be really complex to deal with. Now that you have a good overview of the Swiss Army knife architecture anti-pattern, I will now pass it on to Cal.
Thank you, Hilda. So now we're going to talk about the vendor lock-in anti-pattern. So this type of anti-pattern is also known as a product-dependent architecture or a bondage and submission and Pottersville. The most common is Pottersville. The root cause for this type of anti-pattern is due to pride or ignorance, just lack of attention, sloth, apathy. The unbalanced forces involved are management of technology transfer and management of change. So more about vendor lock-in. So as we discussed before, that its other name is Pottersville, and that comes from a very popular film called It's a Wonderful Life. And in this movie, there are two alternatives realities that are basically presented. In the first one, the city is controlled by a banker who refuses to give people control over their own lives and property, and essentially this results in a culture of hostility and envy between the citizens. So that's why this vendor lock-in is known as Pottersville. Now, this software architecture, it adopts this sort of technology where its implementation is entirely reliant on the vendor itself. The upgrades that can be made result in software changes and compatibility issues if they're made by the vendor. So, in order to keep the system in a flow and to keep them synchronized, maintenance is required whenever the upgrades happen. So, essentially, whenever there's a new product or there's some sort of delays or expected delays that are happening. This could cause schedule slips, inability to complete desired application, software features, and thus the essential, this is the root description as to how uh, vendor lock-in anti-pattern occurs. So, the vendor lock-in anti-pattern is acceptable when a single vendor's code makes up the majority of the code needed in an application. Now, there are various causes as to how this happens. The first cause is that the product varies from the published open system standards because there is no effective process for the standard. That's intuitively that makes sense. The second one is that the product is chosen solely on the basis of marketing and sales data rather than a more thorough technical evaluation. There is no technical approach for isolating application software from direct dependency upon the product. Therefore, the application programming requires in-depth product knowledge, and thus the complexity and the overall general aspect of the product technology greatly exceeds that of the application needs, and therefore this direct dependence upon the product involves loss management of complexity of the application system architecture or of the architecture overall. These are the root causes for this sort of anti-pattern. With every cause will come some sort of symptom or some sort of consequence. So there are four major causes over here. The first one is commercial product upgrades drive the application software maintenance cycle. And this, because of these promised product features, there's delays, or they're just never delivered. This could cause some sort of feature or deliverables missing. Now, the product or the final product can also vary significantly from the advertised open systems as a standard. And if the product upgrade is missing entirely, as discussed in the second point, then a product repurchase and reintegration is often necessary. So these are the main four problems due to the causes. So we've discussed the causes. Now we can go and look at the solution. The solution is that the isolation of an application software from a low-level architecture is needed, meaning this infrastructure could include anything: the operating system, the security mechanisms, the low-level mechanisms, the middleware. So essentially, it just needs to be isolated. That's it. Second, changes in the underlying infrastructure are anticipated within the life cycle of the affected software. Meaning, if a new product is released or planned migration, this essentially could result in a more convenient programming interface. And that is the need to basically solve this issue. The level of abstraction provided by the infrastructure is too primitive or flexible for the intended application in the system. Therefore, it is desired to provide consistent handling of the infrastructure across multiple platforms. Some heavyweight conventions for default handling of infrastructure interfaces must also be provided. Multiple infrastructures must be supported, not just provided, but this just has to be support for them, either during the life cycles or concurrently. So essentially, this solution entails creating a layer of software that abstracts the underlying infrastructure and the product-dependent software interfaces. This layer creates an application interface that separates the application program from the UPI or from the API that's being used altogether. Now, the application interface should also provide a convenient language-specific interface to desired capabilities. Now, the layering software should provide default handling of some infrastructure calls and parameters, but exposes other details when appropriate. So when we use this isolation layer across multiple domains, then there is consistency, the isolation is efficient, and there is transparency within the system. To migrate the isolation to new infrastructures, the update needs to be on a regular basis as well. In all cases, maintenance for the same application within the same off software interface needs to be in consistency. And this is the solution to overcome the vendor lock-in anti-pattern. Thank you.